All right, I wanted to talk a little bit about some of the advantages of open source gaming. One of the most important aspects of open source gaming is the ability to attract people to the project, be it developers, players, or whatever, due to the openness of the open nature of the project. I think as long as you have a pretty good idea and it's well organized, you're inevitably going to attract other developers as well as players and a community that build up around it. This can really help your project out, both long and short term. Just for example, when we decided we were going to switch to a skeletal model format, we kind of put the word out there, and another developer from actually even rival competing game got wind of it, and he offered his assistance because he was, at that time, thinking of doing the same thing, and he wanted to create a format that could be used in a variety of open source engines. So we worked together, came up with ideas together, and he built the format, and he would pass some things off to me and ask me what I might want to see in it, with the assumption that I would use it in my engine. There were a lot of nights that we would pass code back and forth on IRC, and he really helped out. When it came time to take it to the next step and implement the ragdoll physics, now, I was doing it with a different method than he had, but he had a little bit of experience with that, and you know, he would look at my code and see where I was going wrong, which was pretty much everywhere, and it really proved to be a valuable asset. So you can really see that there's like a certain camaraderie between these open source game developers. You know, you have your communities for each game, but a lot of these communities actually interact with each other and share information. And long term, obviously, you know, the more people feel involved with a open source project, and the more the community feels like they have a say in things and input, the longer that project's going to last. Okay. Now, despite all these advantages, open source games do face some significant challenges. One of the biggest problems is being able to keep up with commercial games, and not just in technology, but in the artwork as well. You know, when it comes to the technology side of it, you know, it's a difficult thing to keep up when, you know, these commercial games have teams of developers that are on the cutting edge of technology. But the good news is, you know, there's a lot of good open source examples out there that you can use as templates to actually improve your engine. You know, it's not always as easy as cutting and pasting code. Sometimes it takes years to implement an idea. But the good news is you really don't have to start out a generation behind anymore. You know, there's already some engines out there that have done a great job of closing that technology gap. And, you know, you really don't have to reinvent the wheel unless you want to. And there's some value in that as well. You know, people sometimes want to do things for themselves and learn, which is something that I did. Now, another part of this catching up is because the advancements in gaming technology have hit a bit of a plateau in the last few years. If you remember the 90s, you know, we went straight from 2D to the faked 3D that they kind of called 2.5D of Wolfenstein and Doom. By the mid-90s, we had full 3D engines like Descent and Quake. By the late 90s, OpenGL and DirectX had gotten integrated into games, and that's when things really took off, because once OpenGL, or you know, once this happened, OpenGL, you know, the changes in OpenGL and DirectX, the games kind of followed right along with their advancements. By 2004, you know, you had per pixel lighting and vastly improved shadowing, and most of the open source engines at that time were lagged pretty far behind. But that evolution slowed, and it's allowed these applications to catch up. And one of the biggest reasons is because in open source environments, the passing back of the information and technology, it's not something you're going to see in a closed source environment as much. You know, one engine will solve a problem or create a new feature, and you will see the other engines just kind of fall like dominoes right after that. And they'll go back and forth with it. It almost creates like a vortex of technology. And that's something that really is a really important aspect of the open source part of it. Open source examples, those really helped us to improve our rendering techniques. We started out with an engine that was written in '97, so in 2004 we had a lot of catching up to do. You know, we also had to make the thing not only look better, but it had to run more efficiently. The first thing we did is we ripped out the renderer, the old open-ended GL begin, GLN type commands, and we replaced them with compiled vertex arrays. Beyond that, we went to vertex buffer objects. We reorganized a lot of the renderer, batching things up, making sure things like static meshes weren't being rebuilt on every single frame. We had to improve the lighting, obviously, and you saw that progression in the slides. It meant learning about and using the OpenGL shading language. And this was done, you know, to do the per pixel self-shadowing that we saw in Doom 3 and games beyond that. It also meant writing our own shadow system, which is kind of a unique way of doing it. We do a combination of shadow mapping and blurred stencil volumes, and that's something I'll also talk about in the 2-hour seminar on Friday, which is at 9:45, by the way. We replaced the entire sound system using OpenAL, and we also integrated the Open Dynamics physics engine, and that was so we could do ragdoll physics. Now, we couldn't have done any of this without very well-documented open source examples, be it online, books, precedents, and other gaming engines. It really helps to have a good template, and I think it's vital to repay the community with your own templates when you come up with your own ideas. And to that end, that means it's also very important to document your code as thoroughly as possible. And that's not just so that people can use your code for their own projects, but it's also so that people can learn about your code and maybe even make improvements back to your project. Okay, as I was talking about, one of the important things is the community that you build around an open source game, and one thing that's going to really attract people to that community is the use of free or open source tools to create your content. Or compile the code. You know, in Linux, you know, basically you got a GCC and a makefile and you're good to go. In Windows, there's a variety of free compilers, including Microsoft Visual Studio Express, which isn't a bad IDE, really. Using free programs like Blender or GIMP, that'll make it easier for people to improve your art assets, if that's something you want them to do. If you have proprietary game content, such as, you know, I'm thinking like level editors and things like this, it would be important to write your own tools so that people can use these tools to build content for your game. And that's not just for the developers, but that's also for community people who, you know, they want to add their own third-party maps and things like that. The more interactive a community is in this fashion, you know, like I said, the more longevity your game's probably going to have. Okay, so one of the things that people talk about with open source, and not just in open source really, but the phrase release early and release often, a lot of people look at that as a negative, but in open source that can be a positive. You have to weigh the notion of possibly turning off people to your project if you release it a little too early and it's not very polished, against getting the name of the project out there and attracting developers. Now that might depend on the stage you're at with the game, but the thing you have to remember is gamers can be pretty fickle, and if you know you have a project out there that's half done or broken, they might be forever, you know, that project might be forever buried under the weight of negative criticism and reputation. So my personal opinion and experience on that is don't really release it, or at least don't advertise it as a playable game and have it not be a playable game. You know, don't put it out there if you know there's something wrong with it, something that you would immediately want to be changing as soon as you put it out there. And that can be really important, you know, especially for like a multiplayer game where you have issues with, you know, generating enough of a player base where you have people playing against each other. It's kind of like a chicken versus the egg thing here. People download your game, they'll get on a server and they won't see anybody on it, so they'll quit because they don't think anybody's playing it. So you have to ask yourself, how am I supposed to get people to play it if nobody's going to play it because nobody's playing it? my thought of that is basically early on, it's not a good, it's a good idea not to really worry too much about a player base. Focus more on the development and attracting the developers to help you. Build a small community around the game. These players and community members, they can provide you some very valuable feedback to tweak the gameplay and other things, find bugs before you actually put it out there to the general public, and you don't want to put the broken game out there. Once it's a little more polished and playable, then that's when you want to really go all out, hype the game up, put that big release out there, and get that big cluster of players together that will actually be online at the same time and play each other. Now, if you're doing a single-player game, none of this applies, but for multiplayer games, which is kind of becoming the norm these days, that's pretty important. You want to keep all of this very organized and well mapped out, particularly on the development side. I think that small core groups of developers that can accept and reject contributions, such as patches and bug fixes, is probably a better idea than having a huge team of people that all have access to the code directly. I've seen a lot of projects that start out this way, and they wind up becoming a huge mess, people stepping on everybody's toes. If you have 15 people with access to your Subversion or Git repo, and they're all putting in their own changes in source code, you're going to wind up with a lot of bugs and a lot of developers infighting and stepping on each other. So I think a smaller team that has common goals can probably keep it in a more positive direction. One thing you got to do, and I've talked a lot about rendering and sound, and I've been talking about that over the last couple of days here. You really have to, with a game, you really have to, and pretty much any software, you really have to address all aspects of it. No matter how good your game looks or sounds, if the gameplay is subpar, it's going to fail. So gameplay is really important. You have to consider things like replayability factor, immersion, challenge, mental stimulation, or competition, particularly in a first-person shooter game, which is the genre I focus on. I can't really tell you what makes good gameplay for any specific project. It varies between genres, and there's a million different opinions for each of those genres. The best thing you can do is listen to the player feedback and allow that to influence and shape your game a little bit. With Alien Arena, we use the community's input as a very valuable tool. A lot of the features that we have, like our health system and the little reward bonuses you get and the power-ups, some of the levels, some of the weapons even, this was all really born out of community input. They were very vital with that, and they continue to be so.